Welcome to clickmyproject.com. COSAC, a framework for combinatorial statistical analysis on cloud. Now we see about the abstract of our project. The data explanations is leads to demands for big data processing in data centers that are distributed at different geographical regions. Data computation, storage and communication in data center, which are very effect and expenditure to data center providers. So this there is not have a load balancing concept. So these are have worked by single data center. It have take large time to execute and large time to move the cost. So we have the computation task were conducted only when the corresponding data is available due to tight coupling becoming data. So we implement the coupling concept to assign the task data placement and data movement in influence way to the expenditure of data centers. So we have implement to execute the available job by performing the segmentation process and allocate it to appropriate data centers which are ideal and which are not in busy. So this can be performing the map reduce concept by implementing the Hadoop concept. So we have reduced the available data from the memory by using the map reduce concept. So using this map reduce concept, we have achieved the load balancing in by statistical analysis, and also we have performed linear and non-linear statistical analysis concept. We have implement which is better than other. So we have identified the data center and the size and then another capacity for each job. If the job is income in our process, we have analyzed the job first, and then we have segment the job into 5 static, and then we have select any data center is dynamically whatever the jobs are available to execute in any data center, the job is automatically sent to current data center in runtime. So we have execute the job by using the map reduce concept. So we implement the map reduce concept by achieving the load balancing task is easily. So next we see about the data flow diagram. So this is the data flow diagram. First start our project and then data uploading. The data uploading is that we upload our input file. Now we have input the census data as input, and then segmentation process. We have segmentation implemented by segment the input file as static. So we have segmented or divided into 5 parts as same size, and then identify the data center. We have first creating the data centers as a different capacities, and then identifying the data center which data center is apt for executing this our job. So we have analyzed the data center first, so this can be applied the load balancing concept. So and then after task assignment, in this task assignment we have identified the task and perform the map reduce concept. So we have reduced the execution time by using the map reduce concept, and then we have implement the large file, that means a big data concept on Hadoop to achieving the map reduce concept, and then task processing, and then after the task processing we have find out the execution time and that arrival time for all that for each jobs, and also find out the data center capacities. These are all completed. We have performed the minimum integer programming and non-integer program, that means optimization and non-optimization concept. In this concept we have identified which is best one for implement the statistical analysis. This process is used for analyzing the statistical analysis on combinatorial clouds. So this we have identified and then produce the performance evaluations. In performance evaluation we have produced the data size for graph. We have analyzed the data size for input and output records, and we have produced the cost and performed the evaluations. Let us run our project. Click the home page.java to run us on Hadoop. To click the home page, OK, and then choose an existing server and click finish. Our process is start for running. Click load data to select our input file. Our input file in our the GAUS national.txt is our input file to load the data. Our file is uploaded successfully and click OK and then show the census data. So data is viewed successfully. This is the census data is our input for our project and click this button. Now we have to segment our input files. To click segment. The file is segmented successfully. Our file is segmented into 5 packets and is assigned as name as job 1, job 2, job 3 and job 4 and job 5 and click next. And we have a 5 data center and each have static allocated space for each of them and click next button and select any one of the job and click submit. So our job is allocated to appropriate data center and which is ideal and which is apt for to executing our job. So we have allocated the job to data center 3. So we have now run the data center 3. So is a dc3.java. To click run as on Hadoop and click finish. So now enter the port number and click connect and now enter this database and again enter the IP address and click the port number and click request button. Our client is connected. Our job 3 is sent to our server and click accept this job and click receive. Our job is assigned to server successfully and now the job is sent to data center 3 and for execution the job and click execute the job. Our process is to perform the map reduce concept. After that map reduce is completed and click this button to get the execution time for our project. The total processing time and process count and the task arrival rate is also displayed. Then now we have to show the status of the execution list and click the execution result.java and click on run on Hadoop. Now we have clicked the view detail about the execution result. This is the job processing time and their cost and the arrival data. So these are all the jobs are correspondingly executed on each data center and how much they time take to execute the each task and how much cost they will execute it in a data center and then when that we have come from each data center. So calculate the arrival date for each jobs. Next click the next button. We have now calculate the non-joint optimization for our process. So we get the operation cost calculation. To click get P and the flow of chunk. What about the chunk should be calculated and then to show the weight of our each job to calculate it, click get W and the total energy of the cost is also calculated. Now we have to calculate the non-joint joint optimization. And also we have calculate flow of chunks and the transmission rate and weight and the total energy cost. Now we have comparison for our data size for each jobs. Click data size.java. This is the data size comparison for the joint optimization and non-joint optimization. So here see that the joint optimization is better than the non-joint optimization. We have reduced the load balancing concept in our processor. Thank you.